Hey everybody, happy Wednesday. Sorry I wasn't in class today. I was out working on your district common assessment with a bunch of old curmudgeon-y dudes. So hopefully you got ahead in your reading. And if you weren't already on point, hopefully you got caught up in your reading. It's really important that we're getting that reading done. It's the only way you're going to be able to pass that AP exam. We just don't have the time to cover everything you need to know to get an A in this class or even pass the exam. So hopefully you guys are getting that done. But today I want to swing back to something we talked about yesterday, or not yesterday, I guess it was Monday. And we talked about population density. And basically we asked, when we're looking at this choropleth map, or cartogram, I'm sorry, even though they have the highest population, are these places overpopulated? And basically we're going to talk about how we measure overpopulation. So you're going to want to get your notes ready. We're going to go pretty quickly so you can get this stuff and we can start using it tomorrow. The first thing I want you guys to talk about is arithmetic density. Arithmetic density. Think arithmetic. Arithmetic density. And basically that's just math. Straight and simple. So basically arithmetic density is just the number of people divided by the amount of land. It's really simple. It's the math guy's favorite one. Essentially, I'm going to divide the number, I'm going to take the number of people, the population, and divide it by the square miles of where I'm looking at. So if we take a look here in the darker areas, we see that India is really high density. Mathematically, there's a super high density, right? If we look over here, where are we at? So Japan, super high density. South Korea, let's go. Look at how the densities are much bigger in these smaller areas and more impressive in these larger areas. Over here in the US, third largest country in the world by people, not that dense in terms of people per land. So we as geographers, though, know there's a couple problems with this. We are committing the act of induction when we use this one. If we look at arithmetic density in the US, we know that most of the people in the US actually hang out in the southeast of the United States, right? They don't hang out in the Midwest, and only a bunch are on the West Coast, but not too many in the South. But this map kind of colors them all in. So arithmetic density is going to say, hey, in this country or this place I'm looking at, everyone is kind of spread out equally. And as geographers, we know that we should kind of keep an eye out, which is why we have our second measurement, which is physiological density. And physiological density is the total population per divided by the amount of arable land. So when we take, or arable land is the amount of farmable land in a place, or useful land as we as geographers are going to call it. It's what we can use for agriculture. So this changes our picture a little bit, right? Now that we see the US, we have actually tons of arable land. There's less than 250 people per kilometer of square arable land, which means we have lots of extra land. Look at Canada, there aren't that many people, and there's lots of land that could be used. But look over here, but what about the jungles and all that stuff? Maybe there's not that much arable land. Maybe the population is crazy high. When we look at India, numbers are pretty okay. China, pretty okay. Japan, slogged, right? All of their usable land or their arable land is taken up. This gives us a different picture. And so if we zoom in, let's say we're going to zoom in on Egypt here. We're going to zoom in, and it's going to give us a little more detail. Now when we look at the use of arable land, we see something that might be pretty obvious. Why do the people live in this configuration, right? What's the why of where? It's because that's the Nile River, right? Egypt has 84 million people, and they all live on that river. But there's not that much land in Egypt, or because there's not that much land. Sorry, I got tripped up on my own slides. I don't know why I put the big but right there. It really threw me off. They get stuck in this place because there's no other arable land, and the best way to show it is actually just to show you a picture of the Nile River, right? You can see all that desert area out to the right and left. No one can live there. It's just high desert. Here's an even better picture at nighttime. Yeah, you see a couple oases out here, but mostly, all those people, those millions and millions of people, all live right here on the Nile Delta. The next up is, where's my title, is agricultural density. And this is a different way of measuring arable land. So instead of saying population, total population on arable land, it actually says forget about the population. What's important is who's using the land and how people are using the land. And this measures the total number of farmers, people who actually use the land, compared to arable land. So you take the number of farmers and you divide that by the square kilometers or miles of your actual land. And this is going to give us a whole different picture. This is going to allow us to measure a country's ability to produce food. So you may have a bazillion people, and it might be the most resource dense and arable land you've ever seen, right? You might be in the Garden of Eden, but if you don't have a farmer, you're not going to be producing any food. So the agricultural density basically shows us how many farmers are in the space that is used for farming. It's pretty nice, and it gives us these economical differences. So now when we look at India, we see that they have tons of farmers, where on the last one, I don't want to go back, it's so much clicks. When we go back and looked at China and India, when we did physiological density, it was pretty much similar. But now when we see it in terms of who's farming, well, in India, we have a butt ton of farmers per square mile, right? So India is really utilizing their agriculture. So what can that map tell us, right? It can tell us who's using their land and how much they're producing, but is it a perfect measure of production? Not really. When we look up here at Great Britain on northwestern Europe or in Western Europe, we see that it actually has a low amount of agricultural density, right? There aren't that many farmers on arable land. And then we compare it to, I don't know, off the top of my head, Laos, right? We're going to go over here. We see that there's a huge number of agricultural, actually Laos is... Yeah, I can't see it on this map. Someone show me later. We see that there's a huge ratio of agriculture density. They have tons of farmers. And the reason for that, it actually shows us a more interesting thing. In Britain, farmers are industrialized. Remember, development is key to almost everything. It takes 2 farmers to do the same amount of work that it takes hundreds of farmers to do in Laos, right? See them all picking grain by hand? I guess those are rice paddies. You could really ESPN the garbage out of this, out of these pictures, right? There's 2 men cutting through fields that in these pictures, it takes hundreds of people to do. All right, the last thing I want to show you, those things are on the quiz. You're going to want to pull out your notes on demographics again. I want to show you a term called demographic momentum. We skipped this one in class the other day because it is just crazy hard to explain. I'm sorry, I'm not even presenting. Demographic momentum is basically the idea that even when a population stops growing, when they hit the replacement number, families are only having 2 kids per family unit, right? So they're only replacing themselves, they're not growing. Basically, it's the momentum of those generations that continues to increase the total population. So even though people are having less kids, it's going to take a long time for that to catch up to total population. So I've got this GIF here to show you. We're going to have to wait for it to restart here. But basically, you're looking at the growth pyramid. Let's see. Will it restart? I should go back to the top. So we're going to start on something like this, a growth pyramid. And you'll see that even though these families are having less and less babies, the changes are getting less and less in between each one. These people are still going to replace the next thing above them, and they're going to have 2 kids. So the total population is going to grow, even though people are having less kids than before, and the growth rate has slowed down, the total population will still increase. And it looks something like this. Notice here, these people are starting to fill in where all these other people will. Even though it's not growing, it's filling in. But you'll notice that there's more blue on the map now than there was. So even though these people aren't going out to the left or they're not growing like a pyramid, the full color of this graph is starting to get bigger. So there's a higher total population, even though the growth of the population is leveling out, or the growth rate of the population is leveling out. And that is the last thing I promise on this video. Hopefully you guys got that. There is a quick quiz tomorrow on population. I'm going to see these notes the first thing as you walk in the door tomorrow. Make sure you get it done. You all are rock stars. You know what to do. Make sure you do your reading. If you're behind, get caught up tonight. You can do it. I believe in you.